6.3. We're going to perform function operations that you're familiar with, and then also composition of functions, which is probably new for you. All right. So our objective is to perform function operations, add, subtract, multiply, and then divide. Composition is actually where you take one function and you plug it into another function and see what you get. All right, so our operations of functions, like I said, addition, subtraction, multiplication, division, work just like adding, subtracting, multiplying, and dividing polynomials. You've got f of x, for our example, equal to 3x, and g of x equal to x plus 3. So if we define h of x as the sum f of x plus g of x, we just replace f of x with 3x, because that's the function rule for f of x, and we replace g of x with x plus 3, because that is the function rule of x plus 3, of g of x. And once we have 3x plus x plus 3, we just combine like terms. So 3x plus x is 4x, and then plus 3. For subtracting, similar idea. F of x is still 3x. G of x is still x plus 3. So when we do 3x minus all of x plus 3, we would distribute the minus. 3x minus x is 2x, and then the negative would be distributed to the 3, so we have 2x minus 3. For multiplication, f of x times g of x is going to be 3x times x plus 3, and so we distribute the 3x to get 3x squared plus 9x. For division, we just do f of x, just 3x, divided by x plus 3, and we just leave it as that. The domain of h consists of all the x values that are in the domains of both f and g. Additionally, the domain of a quotient does not include values for which g of x equals 0. For instance, our little example here, we would not include the value negative 3, because if we set x plus 3 equal to 0, we get x equals negative 3. That would give us negative 3 in the denominator, which would make the whole division problem undefined. Okay, so we're going to let f of x equal 4x to the 1/2, and g of x be negative 9 times x to the 1/2, and we're going to find the following. F of x plus g of x, and to do that, we just add the two function rules together. So 4x to the 1/2 plus negative 9x to the 1/2. Well, adding a negative is the same thing as subtracting a positive. So 4x to the 1/2 minus 9x to the 1/2, we get negative 5x to the 1/2. Please notice that we just checked that they have the same exponent to make sure they're like terms. Nothing happens to the exponents in this case. We just go, oh yeah, we've got an exponent of 1/2, so these are like terms. So we just combine the coefficients. F of x minus g of x is going to give us 4x to the 1/2 minus negative 9x to the 1/2. So that's going to be 4x to the 1/2 plus 9x to the 1/2. We have like terms because we had the same exponent for our x's, and so we just add together these two coefficients, and we get 13x to the 1/2. All right, now we're going to multiply and divide. We've got f of x equals 6x and g of x equals x to the 3/4. So let's multiply them together. So we do f of x times g of x by replacing the function names with the function rules. So 6x times x to the 3/4. Okay, our coefficients are 6 and 1, so 6 times 1 is 6. And then remember, we add our exponents because we had the same base. Now remember, plain x has an understood exponent of 1, so we get 6x to the 1 plus 3/4. So 4/4, which is equal to 1, plus 3/4 is 7/4, and so we have 6x to the 7/4 power. F of x over g of x, we just plug in the rules, so we get 6x divided by x to the 3/4. Now we look to see if we can reduce this. We can. We have x to the first over x to the 3/4. They had the same base, so we can simplify by subtracting the exponents. 1 is larger than 3/4, so we'd have 6x to the 1 minus 3/4. Again, 1 is 4/4 minus 3/4 is 1/4, and so we get 6x to the 1/4 power. All right, so let's look at actually an example where people would use this in the real world. For a white rhino, heart rate R in beats per minute and lifespan S in minutes are related to body mass M in kilograms by these functions. R of M, so the heart rate as a function of mass, is equal to 241 M to the negative 0.25. S as a function of M, so lifespan as a function of mass, is equal to 6 times 10 to the 6th M to the 0.2 power. All right, so we want to find R of M times S of M. So we're going to take and replace the function names with the function rules. And then we're going to explain what it means. So R of M times S of M. R of M was 241 M to the negative 0.25. S of M is 6 times 10 to the 6th times M to the 0.2. So 6 times 10 to the 6th is that's the coefficient. It's just written in scientific notation. So we're going to multiply our two coefficients together. So we're going to have 241 times 6 times 10 to the 6th. And then we have the same base. And remember, when you multiply two power expressions with the same base, you add the exponents. So we're going to add negative 0.25 and 0.2. All right, so if we simplify, the way you simplify this coefficient is you just do the 241 times 6 to get 1,446 times 10 to the 6th. M to the negative 0.05, because negative 0.25 plus 0.2 is negative 0.05. We want to put this in scientific notation, which means we just have one decimal to the left, one value to the left of the decimal, excuse me. So we're going to use scientific notation. So we're going to move this decimal over 3 places, so we need to increase the exponent by 3, and so we get 1.446 times 10 to the 9th M to the negative 0.05. Okay, so what does this mean? Well, we took the heart rate and we multiplied it by the lifespan, so that gives the total number of heartbeats for a white rhino over its entire lifetime. That's kind of cool. So based on mass, they can predict how many heartbeats the rhino has for its whole entire life. Okay, so that's just been a review of like the different operations, adding, subtracting, multiplying, dividing, that you've already known about, and just looking at it with some different types of functions. Now we're going to look at the composition of functions. The composition of a function g with a function f is h of x, and that's going to equal g of f of x. So what that means is we take x, we plug that into f, we get an answer, and we take that answer and plug it into g. The domain of h is the set of all x values such that x is in the domain of f. Okay, so that has to be defined. And then f of x has to be in the domain of g. Okay, you have to be able to plug x into f and get a value, and then take that value and plug it into g and get a value. All right, so we're going to let f of x equals 2x minus 7 and g of x equals x squared plus 4. What is the value of g of f of 3? So what this means is you're going to take 3 and plug it into f. Whatever answer you get there, you're going to take and you're going to plug into g. Okay, so the first thing you have to do is find f of 3. You have to evaluate the function f for the value 3. So we look at our rule, and our rule for f of x is 2x minus 7. That means take whatever input you are given, multiply it by 2, and subtract 7. So when we have 3, we're going to plug that in for x. So we're going to do 3 times 2 and subtract 7. So that's going to give us 6 minus 7, which is negative 1. Okay, so f of 3 is equivalent to negative 1 for this problem. So that means that g of f of 3 is equal to g of negative 1. Okay, so we figured out what f of 3 is. It's negative 1. So now we're going to use negative 1 as our input for g. Okay, so the rule for g is input squared plus 4. So we're going to have negative 1 squared plus 4. Negative 1 times negative 1 is 1, plus 4 is 5. Okay, so what this means is when you take 3 and plug it into f and take that result and plug it into g, you get 5. G of f of 3 is equal to 5. So the correct answer is D. Now you can do the same process, but for x in general. You can come up with a general rule. In the previous example, we had a value for x. Now we're just going to look and see, well, what is the overall rule? What happens to x if you g it and then f it? Okay, so we're going to take x, we're going to plug it into g, and then we're going to take that result and plug it into f. Okay, so for here, they already tell us what it means to take x and plug it into g. We have that rule for this problem. For this problem, g of x, the rule for that is f of x minus 2. So what we're going to do is we're going to use this input and we're going to plug that into into f. Okay. So we're going to do f of x minus 2. So you take the name of g of x and you replace it with the rule of g of x. So f of x minus 2, and this is going to be our input for f. So f of x is 4x to the negative 1. So f of any input is 4 times the input to the negative 1 power. Since our input is now f of x minus 2, when we take that and put that into f, we're going to do what the rule says. So we're going to have 4 times f of x minus 2 to the negative 1, because f of x minus 2 is my input. So the rule is 4 times input to the negative 1. So we've got 4 times input to the negative 1. Well, to the negative 1 power means just the reciprocal. So we have 4 times 1 over 5x minus 2. So 4 over 5x minus 2. What if we go in the other direction? What if we figure out what g of f of x is? So that means f of x is going to be our input into g. So let's replace f of x with its rule. The rule is 4 times x to the negative 1. Okay, so we've replaced the name f of x with the rule for f of x, 4x to the negative 1. And so this is going to be our input for g. Remember, g is 5 times the input minus 2. So we're going to have 5 times this input, 4x to the negative 1, minus 2. And now we simplify. So 5 times 4 is 20, times x to the negative 1 minus 2. X to the negative 1 means 1 over x. So 20 times 1 over x is 20 over x minus 2. All right, you can even compose a function with itself. We can do f of x. So you just work from the inside out. Okay, so we're going to replace f of x with the rule for f of x. Okay, the rule for f of x for this problem is 4 times x to the negative 1. And now we're going to take this 4 times x to the negative 1 and put it into f of x. So we're going to have 4 times our input, 4x to the negative 1 power. Okay. So if I raise everything in these parentheses to the negative 1 power, I'm going to get 4 to the negative 1 and x to the negative 1 times negative 1, so that's just x. So 4 times 4 to the negative 1, this 4 has an understood power of 1. So 1 plus negative 1 is 0, and then times our x. 4 to the 0 is 1, times x is x. Okay, so go ahead and try the problems to try on your own. We'll go over those in class next time. I will see you then. Come in and see me if you don't understand the lesson well enough to do the problems to try on your own. Come in and we'll talk through it. Okay, have a good day.